Good afternoon. Welcome to the second session of Parabola. So in this session, we'll just write down the some summary that we have obtained from the previous basic sessions. So the first one is, if you recall the standard parabola. So standard parabola is what? We have here y square is equal to 4ax. So this is just another way of writing the parabola. So suppose I have here y square is equal to 4ax. It is here, basically. This is my parabola. So this is my point P, which is x comma y. Then I can think of this y is nothing but its distance from the axis. So y is nothing but the distance of this point P, perpendicular distance of point P from the axis of parabola is nothing but my y, and x is nothing but its distance from the tangent at the vertex. This thing is called as the tangent at the vertex, which we will discuss later on. But still, from the knowledge of calculus also, you can say, yeah, this is nothing but the tangent at the vertex, because this is a 2-degree curve, and then there is a line here which is touching at only one point. So this is called as the tangent at vertex. This is my tangent at the vertex. Tangent at the vertex, and this is my axis of parabola. So now I can think of y square is equal to 4ax as y square equal to 4ax can be thought of y is nothing but distance of P. So distance of P from, say this is y. Y is the height. That means this is nothing but a distance from the axis of parabola. So distance of P from the axis of parabola, this square is equal to 4a. We know it is nothing but the length of lattice rectum. 4a is nothing but the length of lattice rectum into we have x. So x is nothing but this distance, which is nothing but distance of P from the tangent at the vertex. So I can write down distance of P from the tangent at the vertex. The tangent at the vertex. So distance of P from the tangent at the vertex. This is one very important finding. The finding number 2 is basically what? If you look at the same parabola, and suppose I have here, this is not only for one parabola. Whatever parabola we will be deriving, we'll be using the same concept. Okay, the concept remains same. Maybe things can change, but concept does not change. So say this is my vertex, and here I have the focus. So focus was here a comma 0, and this point here, if I look at this point was minus a comma 0. That means if you see here, then we come to know that the foot of perpendicular, okay, foot of perpendicular here, this foot, this point, or say foot of the directrix on axis of parabola. Say I'll be calling it foot. This is my vertex V, and this is my focus. So we'll call it some other names. Let's not call foot. We have to name it some other point. Say I'll write down P per point, perpendicular point P, and this is vertex and this is focus. So if you see here, then vertex is nothing but the midpoint of P plus F over 2, because vertex is nothing but the midpoint of focus and the directrix, this point here, the foot of the directrix on the x-axis. So this is also a very important point. And also, if we see here, then that means these two distances are equal. These two distances are equal. So that's why this becomes the midpoint. So this concept also we are going to use it, that vertex is nothing but the midpoint of focus and the point where the directrix meets the axis of parabola. This is also a very powerful finding. So in this session, we'll be solving some questions based on the very basic property. So let's go have a look at this question. You have here the vertex of the parabola is minus 3 comma 0, and the directrix is x plus phi is equal to 0. Then find the equation of parabola. So we have here, if you have a look, if you take a look here, this is x plus 5. So x plus 5 is definitely going to be here somewhere. This is x is equal to minus 5. And then you have the vertex of the parabola is minus 3 comma 0. So minus 3 comma 0 is here, or else wait a moment, I'll draw a smooth diagram here. Remove all these things. vertex of the parabola, vertex is minus 3 comma 0. So this is my vertex here, minus 3 comma 0. And then I have the directrix. Directrix is what? X plus 5 is equal to 0. So say this is my directrix, x is equal to minus 5. So we want the equation of the parabola. Now let us see how do we get it. Our goal, our goal here is to use the focus directrix property. So this point is minus 3 comma 0, which is nothing but the vertex V. And then we know here, this is vertex. So imagining the standard parabola, then we solve. And then at the end, we come to know what kind of parabola it is. So we don't have to bother about it. This is my focus going to be, which we have denoted by f. And then now I know if I just draw a line, then I know that this is going to be in the same line because vertex and focus, they must be in the same line. That's called axis of parabola. So I know what is this my point perpendicular P. So this point is what basically minus 5 comma 0 because as it is on the axis of parabola and this is line x is equal to minus 5. So directrix is hitting here at minus 5 comma 0. Now I know that vertex is the midpoint of what? P and F. So F I need to find out. So if I can get it, say this is my point. You can imagine say x1 comma y1. So this is my point x1 y1. So now I know that minus 3 comma 0 is equal to what? Minus 5 plus x1 by 2 and then 0. This is anyway ultimately going to be 0 only, so there is no point of finding it even. It's not even required. Let's just write down there 0. So from here we get minus 6 is equal to minus 5 plus x1. So we get to know that x1 is equal to 5 minus 6 is minus 1. So this point I know this is minus 1 comma 0. So minus 1 comma 0 is the focus. So now we know focus and we have the directrix. So I can get the equation of locus. Say locus is some h comma k. So I know that focus directrix property states what? SP is equal to PM. So by focus directrix property, we can have it. So by focus directrix property, I'll be having SP is equal to PM. That method, this I'll be calling it P dash better for simplicity. So SP is equal to PM. This is our property. So SP is what? Distance of minus 1 comma 0 from HK. So I'll be having here square root of right under H plus 1 square plus K minus 0 square is equal to distance of a point from a line. So the line is basically what? X is equal to minus 5. In fact, this we can write on x plus 1 into x plus 0 into y plus 5 is equal to 0. So if you remember that a beautiful formula, then this turns out to be what? Just plug in here. So I'll be having h. So I'll be having here 1 into h plus 0 into k, which is gone. And then plus 5 over square root of a square plus b square, which is 1 square plus 0 square. So we got the equation of parabola here. That means we have now equation of parabola. So equation of parabola turns out to be what? This is h plus 5. So we'll just simply square this. So I'll be having h square plus 2h plus 1 plus k square is equal to, this is what again? H square plus, this is 5h. So I'll get here 10h plus 25. So I end up getting h square cancelled and k square will now become 10 minus 2 is 8h and 25 minus 1 is plus 24. That means I can write down y square is equal to 8 times x plus 3. So this is the required equation of parabola. This is the required equation of parabola. Okay, moving to the next question. So you now have P and Q are respectively the vertex and focus of the parabola. Then we want the equation of parabola again. So for this, what we will do is just have a look. The vertex is here. P is the vertex. So 0, comma 4 is the vertex. And then what we have, Q is the focus. And this is 0, comma 2 is the focus. 0, comma 2 is the focus. Now I need the equation of parabola. So of course, focus is given. That means I can think of applying the focus directrix property. Okay. I can think of applying the focus directrix property. So if you have a look, then this is 0, 4, this is 0, 2. So I should be sure that it's not basically like this. If you just draw a temporary diagram, this for temporary diagram is fine. But if you draw the original diagram, the original diagram, these 2 points are on the y-axis. Okay, so better I'll draw it on the y-axis itself. So let's draw it on the y-axis. Yeah. This is 0, comma 2, and this turns out to be my 0, comma 4. Now see, this point I know is going to be 0, comma 4 is going to be what? Vertex. So this is vertex, and this is nothing but the focus. So if we have seen the parabola, then of course focus lies inside interior point I'll be discussing. But anyway, for the parabola, my parabola, I can be sure it will be like this somewhat, because my vertex is at 0, comma 4 and focus is at 0, comma 2. So vertex is here. Once you can just think of parabola this way, like this. It will be somewhat like this because 0, comma 2 is focus, vertex is 0, comma 4. That means I can think of finding the directrix here. So this distance I know. This is how much? 2. So if this is 2, then this also should be 2. We have seen here because this is the midpoint. So that means this distance must be 2. If this is 2, then this point should be what? 0, comma 6. That means I know the directrix is y is equal to 6. So y is equal to 6 is the directrix for this parabola. So now I have focus and directrix property exactly same like this. So say this point is h, comma k. So again, this is S, this is F, focus. So just simply apply SF is equal to SM. This point I have taken is P, sorry, not S. Take this point to P. This is point P, so I know that PF is equal to PL, perpendicular distance. So just simply apply this. So PF is going to be square root of h minus 0 square plus k minus 2 square is equal to pm turns out to be what? Again, same story. So you want its distance from here. So 0 into h plus 1 into k minus 6 upon square root of 1 square plus 0 square. So now we can square this. So I'll be having h square and then plus k square minus 4k plus 4 is equal to, this is k minus 6 square. So I'll be having k square minus 12k plus 36. So here this k square vanishes and I'll be having h square is equal to 12 minus 4 is 8k and then 36 minus 4 is plus 32. So you can be sure that locus is required parabola, or say locus is x square is equal to 8 common and then y plus 4. So this is my required parabola. Let's go for the next one. So this is quite simple. You can think of pausing this video and then try on your own because you have the focus and you have directrix. So you can directly apply focus directrix property because this question I wanted to make it a bit direct. So you have the focus here at this point, 3 comma minus 4. You have directrix here, x plus y plus 7 is equal to 0. And then I want the locus. So locus of P is this here, say h comma k. So now, generally we have seen standard equations. So this equation is not going to be standard because you can see here the directrix is not parallel to x-axis or parallel to y-axis. The directrix is ultimately making slope -1. So it's some other line, and this focus is also not on the x and y-axis. But doesn't matter because we have focus directrix property. So this is P here, S here, and then I'll be calling again M. So you now have SP is equal to PM. So go ahead with this. So SP is going to be what? H square minus 6H plus 9 plus for this guy, I'm going to have k square and then minus 4. So k plus 4. That means I'll be having k square plus 8k plus 16 is equal to pm square means distance of this point. That means I'll be having here h plus k plus 7 over square root of 2 the whole square. So we just need to expand this. So I'll be having h square plus k square minus 6h plus 8k and then plus 25 is equal to, now start expanding this one, and then these two will be multiplied here basically. This square root 2 square is gone, so 2 I have taken here. Now okay, expand this. So I'll be having h square plus k square plus 49 plus 2 times hk plus 7k plus 7h. I'll bring everything here. So this gives me h square and then 2k square is going to be what again? K square So h square plus k square, and then this is minus 12h and minus 8h is going to give me minus 20h. Oh, this is hk, not, it's not to be multiplied. See, 2h square minus h square is h square, 2k square minus k square is k square, minus 12h and minus 14h is minus 26h, and then this is 16k minus 14k. So 16 minus 14 is going to be plus 2k, and then you're left with this is 50 minus 49, which is plus 1, and then we have here minus 2hk is equal to 0. So this is the required equation of parabola. One should not be confused that what kind of parabola is this. This is the general equation of parabola. In fact, general equation of conic, which we will see in the third session. What is the general equation of conic? How do we get them? Okay, but this is the equation of parabola. Let's go for the next one. So you have find the equation of parabola having length of, let us rectum, 2 units. Axis as x plus y minus 2, and tangent at the vertex is x minus y plus 4 is equal to 0. That means what? There is some parabola whose length of, let us rectum, is 2. This information is useful. Axis is x plus y minus 2. That means this is the axis. X plus y minus 2 is equal to 0 is the axis. And tangent at the vertex is x minus y plus 4. So there is some parabola here whose tangent at the vertex is this, basically. That is x minus y plus 4 is equal to 0. And length of, let us rectum, I know. But that is not required right now. So you should not be seeing this question as this diagram as a scale. It's just a random diagram drawn to understand. Because our goal is to apply what? Because here I have the axis given and tangent at the vertex given. So I can think of this thing. So suppose this is my point P, h comma k. Now I know the equation of parabola is what basically? The distance of point P from the axis is equal to, so distance of P from the axis, so distance of P from the axis is equal to length of latus rectum into distance of P from tangent at the vertex. Distance of P from the tangent at the vertex. This concept we can use. So just simply apply this. Distance of P from the axis is equal to length of latus rectum is given to be 2 into distance of P from the vertex. We'll find out now. I mean, sorry, tangent at the vertex. So let's go ahead. So let's find out distance of P from the axis. So I'll be getting here h plus k minus 2 over square root of h square plus k square is equal to 2 times. Distance of P from the tangent at the vertex is going to be h minus k plus 4 upon square root of, this is not h square plus k square, this is square root of 1 plus 1. 1 plus 1. The coefficient is need to be written here. So 1 square plus 1 square. Here also 1 square plus 1 square. This is squared is equal to 2 times. I'll be having h minus k plus 4. So if I expand this, so I'll be having here h plus k minus 2 square is equal to, this is already 2 and this being squared. So I have here, this will be 2 left here. This will be multiplied here to 4, and then I have here root 2. So basically I now have 4 over root 2, which can be written as 2 root 2. 2 root 2 into, I have here h minus k plus 4. So this is the equation of parabola. One may expand this. Okay, if you love algebra and you like calculating things, you can expand this, or you can even leave it as it is. It depends upon the options, whatever you are given to you. Okay, have a look. Now, if the focus and directrix of a parabola are given, then find the vertex of the parabola. So by the focus and directrix of parabola, we need the vertex. So what we can think of, I have a look. This is my, suppose just random parabola I'm drawing. This is given to be focus, which is 1 comma minus 1. And then you are given the directrix. So directrix will be exactly here. Now I want the vertex of this parabola. I want the vertex. That means I want this point. So this point we know is nothing but the midpoint of this point and this point. That means if I have x plus y plus 3 is equal to 0, so I can think of this point as foot of perpendicular of 1 comma 1. This point is nothing but foot of, because see, this is the midpoint here. If this is midpoint of this focus and this focus, I'll be calling it by some other name, say S better. If this is midpoint, that means I can think of this point dividing this one and this one in the ratio, equal ratio. That means this is nothing but, this F is nothing but, F is the foot of perpendicular, F is the foot of perpendicular, F is the foot of perpendicular of S on the line directrix, on the directrix line. So once I got F, then I'll just take the midpoint of F and S to get the vertex. And vertex is the midpoint of, vertex is midpoint of S and F. So let's go ahead to find the foot of perpendicular. So let the foot of perpendicular be H comma K. Then you must have done how to find the foot of perpendicular of a point in a line. So this is simply H minus 1 over coefficient is 1 is equal to K plus 1 over, what's the coefficient of y here? 1 again. This is equal to minus of, now just plug in all these points here. So I'll be having 1 minus 1 plus 3 over 1 square plus 1 square coefficient. So this gives me, this is h minus 1 is equal to k plus 1 is equal to, this is gets cancelled. We get here minus 3 over 2. So from here h is equal to 2 plus 2, 1 minus 3 minus 1 by 2, and k is equal to minus 2 minus 3 minus 5 by 2. That means I got the foot of perpendicular, which is 1 by 2 comma minus 5 by 2. So therefore vertex is nothing but the midpoint, which is half plus 1 by 2 comma, and then this is going to be minus 5 by 2 minus 1 by 2, which in turn turns out to be 3 over 4 comma minus 7 over 4. So this is the vertex of this term. Next question. So if the locus of the point 40 square minus 1 comma 80 minus 2 represents a parabola, then equation of lattice rectum. Then find the equation of lattice rectum. That means the lattice rectum is lying in which line? Okay, we want this. So let's see. This point is basically what? 40 square minus 1 is taken to be y, x, this is x, and then you have here 8t minus 2 is equal to what? Y. So our goal is to what? To eliminate t, to get the equation of parabola, to eliminate t, to get the equation of parabola, and then we can find out the length of lattice rectum, and that's quite simple. So let's go ahead. One may do anything to eliminate t, and the most easiest part would be you find out t from here and just plug in here. So t will turn out to be y plus 2 over 8. This I'll be plugging here. So I'll be having 4 times y plus 2 over 8 square minus 1 is equal to x. So this part I can write down 4 into y plus 2 square minus this is 64 basically here. So minus 64 is equal to 64x. So I can divide by 4 to get y plus 2 square is equal to 16x plus 16. So you may write y plus 2 square is equal to 16 into x plus 1. Now for this parabola, if you see here, then this is a shifted parabola. This one is a shifted parabola, and the vertex is at minus 1 comma minus 2. So for the shifted parabola, for this shifted parabola, what do we have? Oh, we have x minus 1 comma minus 2. So this is y square is equal to 16x. Y square is equal to 16x. So length of lattice rectum, I know it's going to be 4a, which is 16. So from here I get a is equal to 4. This one I'll keep it. And then focus is basically what? focus is a plus h comma 0 plus k for the shifted one, because original is what a comma 0, shifted is h comma k. So I'll be just adding both. So a is 4 and h comma k. I'll just write down what is the shift here. We have seen this -1 comma -2. This is -1 comma -2, just plug in here. So h is -1 comma 0 -2. So my focus turns out to be 3 comma -2 now. So 3 comma -2 is the focus. Now I know how to find the equation of parabola. So not equation of parabola. In fact, what is required? Or equation of lattice rectum. So if for this parabola, the length of lattice rectum we know the vertex, we know the focus. So focus is what? 3 comma -2. That means suppose this is my parabola, this is 3 comma -2, and then what is given here? Yeah, vertex is at -1 comma -2. So vertex is at -1 comma -2. So for this thing, I can get the slope of this line, which will be axis of. So that means I can get the slope of this. So this is focus S, this is vertex V. So slope of SV is going to be what? -2, or else that is also not required, because this is ultimately what? Y coordinate is same. So this is basically a line parallel to X axis. So its slope is going to be 0. This is anyway going to be 0. So equation of lattice rectum you could directly write